Okay, so the next question that we have is question number 5, which is a rod of length 12 centimeter moves with its ends always touching the coordinate axis. So you have a rod of 12 centimeter and it's always moving with its ends always touching the coordinate axis. Determine the equation of the locus of a point P on the rod, which is 3 centimeters from the end in contact with the x-axis. So let's suppose that the rod is somewhere over here, and take this as point A and B. Take this as point A and B, and there is a point, and the length of this is basically 12 centimeters. You want to determine the equation of the locus of a point P on the rod, which is 3 centimeters from the end in contact with the x-axis. So if this whole thing is 12, so then 1/4 of that, 1, 2, 3, and so somewhere over here, I take a point P as x comma y, and this length over here is 3 centimeters. Is 3 centimeters, and so the rest of this length is going to be basically 3 plus 9 is equal to 12. So this is 9 centimeters. So now in order to so you can imagine that this rod is moving. If I imagine that this rod goes all the way down here, meaning that this point goes to the origin, so then or let's suppose that first of all the rod is basically a vertical rod over here, and then so your point would be somewhere over here. As you move the rod, then basically it will have a path over here. The point P over here will have a path which will be something like, I need to imagine this in my mind, that you have basically you have the coordinate axes so you have the coordinate axis, and then you have a rod exactly vertical on the y-axis, and then imagine that this rod is exactly over here, and then it just keeps moving down over here, and in such a way that then point A gradually comes down to the origin. So then that point is going to be, I suppose, so let's suppose that the rod is over here. So let's suppose that the rod is over here, so the point will be here. And then let's suppose that the rod is here, then the point will be here. Let's suppose that, and so on and so forth. So it's going to be this path over here. It's going to be this path over here. Whatever that is, I don't know, but that is a path, and I suppose we can find the equation of this path. So what we can do is that we can draw a perpendicular here and draw a perpendicular here, and there is some sorry, the point is over here, so I can draw perpendicular here and draw perpendicular here. And then there is this angle over here, which is, let's call it theta. There's this angle over here, which is let's call it theta. And then this length over here would be x, and this length, over here would be y. This length over here would be y. This length would be y. And so now what I have from this triangle, let's call this triangle basically, let's call this point P, call this point, for example, M and N. And so in this triangle, MPB or NPB, so in triangle NPB, I can calculate the sine of theta. Sine of theta is equal to basically y divided by 3. Y divided by 3. And in triangle PAM, I can calculate the cos of theta. Cos of theta is equal to x divided by 9. Now if I write sine squared theta plus cos squared theta is equal to 1, that means that y squared by 9 plus x squared by 81, y squared by 9, x squared by 21 is equal to 1, or I can write x squared by 81 plus y squared by 9 is equal to 1, and that is the equation of an ellipse, which means that if I do the equation of this line over here, so this is x squared by, let's say, 81, and this is plus y squared by 9 is equal to 1. Okay. That makes sense. So this will be the path of the point P. So as you can see, this will be the path of the point P, meaning that first the rod is over here, and so if I suppose that even this point, the intercept over here is 0,3. So, and then it keeps moving. And supposing that you do the same thing in this quadrant, and you do the same thing in this quadrant, so what that means is that, so first in the beginning, the rod is basically, let's suppose that the rod is over here. So if this is 3 and basically 3 and 9. 3 and 9. So that there will be a rod somewhere. So let's say take this as 3, then 1, 2, 3, and 4. So this is the rod basically. Originally this is the rod. This is the rod, and this is the point. This is the point that we are talking about. Now if I bring the rod down this much, for example this distance, it's going to be somewhere over here, probably. It's going to be somewhere over here. So this point is moving here. If I bring the rod over here, it's going to be over here, so the point is somewhere over here. Over here, the point is over here. Over here, the point is over here. So it is actually the path, as you can see, is basically something like this, then something like this, then something like this, and so on and so forth. And therefore you will get an ellipse. It's going to be the path of the point P. This is point P, x comma y, which is of course interesting, and it does have a lot of applications in physics. We will get to that. So number 5, that is that. Number 6 is you want to find the area of the triangle. Find the area of the triangle formed by the lines joining the vertex of the parabola, the vertex of the parabola x squared is equal to 12y to the ends of its latus rectum. To the ends of its latus rectum. So the area of the triangle formed by the lines joining the vertex of the parabola, of this parabola, to the ends of its latus rectum. So a parabola is basically something like this, and this parabola in particular is circle, ellipse, hyperbola, and parabola. Okay, so this parabola is particularly, this one is basically something like this. It opens upwards like this, because you have basically x squared over here, so you have it along the y-axis, and here is this is positive, so opens upwards. And we said that this equation can be written as generally can be written as 4ay. That means that I can write this equation as x squared is equal to 4 times 3 times y. That means that your a is equal to 3. Your a is equal to 3. Now I just have a question over here. Let me take a look at these parabolas and I'll be right. Okay, so what that means is that of course the vertex of the parabola, we can assume that it's at the origin. So that is 0, 0. Now if a is equal to 3, I have 1, 2, and 3 over here, and this is your focus, which is at 0, 3 over here. 0, 3 over here. Now the lattice rectum of this parabola is basically this line segment over here. This line segment over here, which is basically right here. And this point over here is 0, 3, because your a is equal to 3. Now all we need to do is find the endpoints, the coordinates of these 2 points over here, and that's basically all we need to do. Now we can do that using the equation of the parabola, meaning that we said that the parabola is, the equation was x squared is equal to 12y. Now I can set basically y is equal to 3 over here, and for example I can say if x squared is equal to 12y, now if y is equal to 3, then it gives me 2x's, meaning that x squared is going to be 36. That means that x is equal to plus or minus 6. So that means that this x over here is positive 6, this is negative 6. Negative 6 and positive 6. So which means that the coordinates of this point would be 6, 3, and the coordinates of this point would be negative 6, 3. So you can do it this way. You can do it this way, or you can use the formula that we found for the length of the lattice rectum, and find the length of the lattice rectum of this parabola. So this parabola over here is x squared is equal to 12y. That means that your a is equal to 3. And the length of the lattice rectum, the length of the lattice rectum of this parabola, of a parabola, is 4a, which is equal to 4 times 3, which is equal to 12 units. 12 units. So if the length of this line is 12 units, and if the parabola is symmetric, then this is going to be 6 units, and this is going to be 6 units as well, which is what we have found over here already. This is 6 units, and this is 6 units as well. So then anyway, whether you find it this way or you find it this way, you will have the coordinates of these 2 points and also this point, and then you can basically form a triangle using these 3 points. Now you have a triangle with coordinates. You have a triangle with coordinates negative 6, 3, 6, 3, and 0, 0. Now the area of a triangle, with 3 known vertices is equal to 1/2 of the absolute value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, so you can take this as point 1, point 2, and point 3, and so this would be x1 y1, x1 y1, x2 y2, x3 y3. So this is equal to 1/2 times x1, which is equal to negative 6, times y2 minus y3, 3 minus 0 is equal to 3. x2 is equal to 6 times y3 minus y1. So this is y3, and this is negative 3 over here, minus y1 negative 3. And x3 is equal to 0, so I don't have to write anything there, because 0 times anything is 0 anyway. So this is equal to 1/2 times the absolute value of negative 18 minus 18, which is equal to negative 1/2 of the absolute value of negative 36, which is equal to 1/2 of 36, which is equal to 18. 18 square units. 18 square units, which is the question number 6 is 18 square units. And the next question is number 7 is a man running a race course notes that the sum of the distances from the 2 flag posts from him is always 10 meters. So notes that the sum of the distances from the 2 flag posts from him is always 10 meters. Is always 10 meters. And the distance between the flag posts is 8 meters. Distance between flag posts is 10 meters. Find the equation of the posts traced by the man. Find the equation of the posts traced by the man. Okay, so it seems that there has been 2 flag posts. You can imagine that, well, there has been 2 flag posts over here, and the sum of the, let's say that the man was over here, or basically let's say that the man, for example, was over here, and if I call this, let's call this F1 and F2, and if I call this P, so PF1 plus PF2 is equal to any other P that you might imagine, considering the kind of trace that he was, considering the kind of path that he was tracing. And this is exactly the situation with a basically, what do you call it? An ellipse, basically. So if you already, basically, we said about these ellipses, we said that, for example, P1 F1 plus P2 F2 is always the same. In the case of an ellipse, we said that, for example, if you have some sort of, for example, let's say call this F1 and call this F2, then you will have, for example, you will have some sort of situation over here. Let's suppose that this is an ellipse, and if that is the case, that if that is an ellipse, then if you take any point over here, for example P or P1, for example, then P1 F1 plus P1 F2, P1 F1 plus P1 F2 is always equal to, for example, P2F1 plus P2F2, P2F1 plus P2F2, and so on and so forth. Any point that you pick over here, this distance is going to be constant. Now, in the case of this man, he was tracing a path, and this condition has been always the case, always 10 meters, and the distance between the flag posts was also 10 meters. So that means that this distance over here was 10 meters, and this distance over here is equal to okay. So now I was thinking about something else, and I think my thought was not really relevant. It seems that in an ellipse, so let any points on the ellipse such that the sum of the distances from P. Okay, so we have in an ellipse, we also showed that basically if this distance P1 F1 plus P2 F2, this distance is always equal to 2a, and a is basically this a is basically, if you take this distance as a, then any point that you pick on your ellipse and find the sum of the distances of that point to the two foci, that's going to be 2a. So now the same thing has been the case with this man, meaning that basically this distance, which is 2a, has been 10 meters. That means that a is equal to 5, and the distance between the foci in an ellipse is denoted by 2c. Now 2c is equal to basically is equal to 10 in this case. That means that c is equal to 5, and there is a relationship between a, b, and c in an ellipse, which we showed a squared is equal to b squared plus c squared. That was also in an ellipse. So then you can say a squared, which is equal to 25, is equal to b squared plus 25, which means that b is 0. That's not possible. That is not possible. I think I'm making some mistake over here. If 2c is equal to 10, distance between the flag posts is 10 meters. Maybe I read the question wrong. I don't know. Running a racecourse notes that the sum of the distances from the two flag posts from him is always 10 meters, and the distance between the flag posts is 8 meters. I see. Sorry, I This is 8 meters. This is supposed to be 8 meters. So if this is 8 meters, that means that 2c is equal to 8. So basically then A is equal to, we found, what we found was that 2A was equal to 10 meters based on this. So that means that A is equal to 5 over here. And also, since 2c is equal to 8 meters, that means that c is equal to 4. Now what basically also in an ellipse there is a relationship between a, b and c, which is a squared is equal to b squared plus c squared. So then you can write basically 25 is equal to b squared plus 16. So b squared is equal to 25 minus 16, which is equal to 9. 9 plus 16 is equal to 25. So b is equal to plus or minus 3. Or you can say that b is equal to 3. So now your b is equal to 3. So now what you can write over here is that x squared, for example, by a squared plus y squared by b squared is equal to 1. So x squared by 25 plus y squared by, for example, 9 is equal to 1. That is the equation of the trace, basically, of the path traced by him, assuming that we take the major axis along the x-axis and the minor axis along the y-axis. So number 7 is x squared by 25 plus y squared by 9 is equal to 1. Okay, of course making this assumption, otherwise you would have to change this by a little bit, changing it to the other orientation, basically. Now there is one more question here, which is an equilateral triangle. An equilateral triangle is inscribed in the parabola, y squared is equal to 4ax. Y squared is equal to 4ax, where one vertex is at the vertex of the parabola. Where one vertex is at the vertex of the parabola. Find the length of the side of the triangle. Find the length of the side of the triangle. Okay. So you have an equilateral triangle that has been inscribed in this parabola, which is y squared is equal to 4ax. That is your parabola. Now one vertex of this triangle is at the vertex of the parabola, and of course, since it is inscribed, it has to be inside the parabola. meaning that you would have basically some situation like this, for example. Some situation like this, and since it's an equilateral triangle, all of these angles have to be the same, 60, 60, 60. Which is easy to find out because it's not that difficult to find out. Okay, so I actually did try to solve this problem in a few different ways, but well, I could not. And then I took a look at the solution, and the problem has actually been solved in a pretty interesting way. Now, I did do it once and I had to go through the steps, but now I can explain it properly. I had to do it a couple of times to understand the solution, but the solution is pretty interesting. Meaning that, let's say that you have your parabola like this. So 1, 2, and 3, and 1, 2, and 3. Let's say that you have a parabola. You have a parabola like this, and if that is your parabola, okay, so let's say that this is your parabola, and an equilateral triangle has been inscribed in this parabola. That means that some situation like this. Now you can imagine that this triangle is an equilateral triangle, and so these angles are all 60, 60, and 60. So you want to basically find this length over here. Let's call it, for example, AB. You want to find the length AB over here, which is the side length of the triangle. I call this point O. This point I can call O 0, 0. Now, if I call this point C, basically what I can do is that I can say that, see, I don't know basically what this length is, so I can say, for example, let OC be equal to some K, for example. Some K, some K, I equate OC to some K. So K is usually just an arbitrary temporary value that we give to some variable, and then using that, basically you can calculate a couple of things, and then using some other method, then you will be able to replace your K with something else which is more permanent in that situation. So that's basically usually how and why K is basically used in solving a problem. So temporarily and arbitrarily, I set OC is equal to K. So if that is the case, then this point over here, these 2 points over here will have some temporary coordinates over here, which means that the x coordinate of the point becomes K, and that the x coordinate of this point will also become K. And since I know that the equation of the parabola is y is equal to 4ax, now if my x is equal to K, then basically I know that y squared is equal to 4ak, which means that y is equal to the square root of 4ak. Actually plus or minus square root of 4ak. So y is equal to plus or minus 2 times the square root of ak. That means that this point up here would be positive 2 times square root of ak, and this point down here would be the y coordinate would be negative 2 times square root of ak. Pretty neat and clean. Now, but of course we need to do something to get rid of this k over here. Now, what I'm going to do is that now, so now that this distance here, as you can see, this distance here is basically 2 times the square root of ak. And what that means is that since this is 2 times square root of ak, you know that AB, which is the distance I'm looking for, is 2 times AC. AB is equal to 2 times AC because everything here is symmetric. So I can write AB is equal to 2 times 2 square root of AK, which is equal to 4 times the square root of AK. So that is basically the length AB in terms of K. Now, there is something interesting that you can do in order to get rid of your K over here. And what that is that basically since basically triangle OAB is an equilateral triangle, you can say that OA is equal to OB. Or then you can say that OA squared is equal to OB squared. Okay, these are simply two lengths, and since the two lengths are equal, so then the square of those two lengths are going to be equal as well. Now OA, using the distance formula, so basically we said that basically originally the distance formula is AB is equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. And of course I talked about this a few minutes ago probably, but I think I didn't say it properly. Now if one of the points is the origin, you can say that, for example, x1 y1 is basically, this point is 0, 0. Now if I use this point in this formula, I can call the distance, for example, OB is equal to, for example, x2 squared minus 0 whole, I'm sorry, no, this is wrong. I can say x2 minus 0 whole squared plus y2 minus 0 whole squared, which is equal to the square root of x2 squared plus y2 squared. Or I can simply write it as, or I can simply write OB, assuming that the coordinates of, I mean, in a general way, I can write it as basically OB is equal to the square root of x squared plus y squared. Any x and y really. Any x and y, the coordinate, the distance of any point x and y from the origin is going to be simply this. So now basically what I'm looking for is the is this length OA squared. So OA is basically, this is the coordinates of the point. So I can write the square root of x squared plus y squared. So that is k squared plus 2 times 2 square root of ak whole squared is going to be equal to 4 times ak. So that is 4 times ak, and since I have to square it, I will square this whole thing, or this whole expression. And then I have OB. Now OB over here, since this is an equilateral triangle, every side, I mean the side that we calculated AB here is the length of every side over here. It doesn't really matter which one. The length of every side is 4 times the square root of AK. So instead of the length of OB, I'm going to write 4 times the square root of AK and square it. So now what I'm going to have here is basically square both sides of this equation. I will get k squared plus 4ak is equal to 16 times ak, or that means that k squared plus 4ak minus 16 times ak is equal to 0. Or I can write k squared is equal to negative, or I can say k squared minus 12 times ak is equal to 0, or k squared is equal to 12 times ak. Oh, I'm sorry, no. So now to solve this equation, I can write k times k minus 12a is equal to 0. I take the k out, so k times k minus 12a is equal to 0. So this means that either k is equal to 0 or k minus 12a is equal to 0. This is not possible, because if k is equal to 0, basically this whole thing doesn't exist, which is not basically what I want. So now this means that k is equal to 12a. So this way, in a very intelligent and smart way, you can find your k in terms of a, and then now you can bring it back over here, substitute it here, and then you will have some expression only in terms of a. So over here we said that AB is equal to 4 times square root of AK. So since k is equal to 12a, I can write AB is equal to 4 times square root of basically 12a squared. 12a squared. So square root of 12 is equal to, I can write this as 4 times 3 times a squared. So this 4 comes out, becomes a 2. 2 times 4 is equal to 8. This 3 remains here. And then this a comes out, becomes an a. So AB is equal to 8 square root of 3 times a. And that is the length of the side length of the triangle that we were looking for. Very interesting way to solve the problem, actually. Okay. So now we are at the end of this chapter. This was chapter 11 of class 11. The next chapter that we have is basically chapter 12. Over here, class 11, chapter 12, which is about three-dimensional geometry. So in the next videos, which is not much really, only a few pages, we are going to be talking about three-dimensional geometry. So I'll see you in the next video, and thank you.